Okay, for question number 10, we're looking at a survey that was done. And so the table shows the results of a survey that asked 2,868 people whether they're involved in any type of charity. A person is selected at random from the sample. And so for question A, we want to find the probability that the person is frequently or occasionally involved in charity work. And so when we use the idea of frequently, so the probability, and I'll use FR for frequently or occasionally involved in charity work, is the probability of being frequently involved plus, because we have an or, of being occasionally involved. And notice there is no overlap. There is no category where an occasionally overlaps with frequently. So we have a total of 429 out of the 2,868 that are frequently, right? The 429 out of the 286 that are frequently, plus occasionally 897 out of the 2,868. And so plugging that into our calculator, we get a probability of 0.462, rounding to 3 decimal places. And so we have the ability to find the or of it being frequently or occasionally. Now the second question asks, what's the probability that the person is female, so I'll use F for female, or not involved? And so here we have the probability of being female plus the probability of not at all. But there is an overlap right here. There is an overlap of female respondents that are also in the not at all category. So we have to get rid of the ones that overlap. And so if we put these probabilities in, the probability of being female is 1394 out of the 2,868, right? Because the total chance of being female is 1394 out of 2,868, or the chance of not at all doing charity work is 1542 out of the 2,868, minus the overlap, which is the 749 out of 2,868. And plugging all that into my calculator, I get a 0.763 chance. Remember, our numbers might be different here, but we get the same idea. All right, and so for C, I get find the probability that the person is male or frequently involved in charity work. So M or frequently. And the number of males are 1,474 out of 2,868, right? Because we follow the male across, and that's the number of male respondents. Plus frequently is 429 out of the 2,868. But there is an overlap. There's 224 men or males that are in the frequent column. And so we have to subtract that overlap out in our conditional probabilities. And so that overlapping of 224 out of 2,868. And plugging that into my calculator gives me 0.585. All right, what we're going to do here is we're going to look at D, and I'm going to write down all the probabilities that happen here. So we want the probability of being female or not being frequently. And so not being frequently really means that we're looking at the complement of being frequent. And there's a couple different ways we can do it. What I did was I looked at the probability of being female plus the probability of being occasional plus the probability of not at all minus the overlap of female and occasional minus the overlap of female and not. And so what I'll do is the probability of being female, so I come over to female, and that's the 1394 out of 2,868. So 1394 out of 2,868 plus the probability of occasionally, which is the 897 out of 2,868. So 897 out of 2,868 plus the probability of not at all, which is 1,542. So 1,542 out of 2,868 minus the overlap of occasional and not at all. And so here's our overlap, where you're female and of those two. So minus 440 and minus 749. So minus 440 over 2,868 minus 749 out of 2,868. And then in plugging all that into my calculator, I get a 0.922 probability. And so when we're doing conditional probabilities and we have an or, we have to double check to make sure that we take care of overlappings. And so for our first part, where frequency or occasional did not overlap, there was no subtraction. But in the other categories where there was an overlap, when we looked at frequent and female, this overlap of 205 had to be taken care of. Or female or not, this overlap of 749. And so we have to subtract out the overlapping areas.